Hello students and welcome back. This week we're going to be moving on to studying the optics portion of our lab. So this is to give a brief overview where we're at. Once, Here we go. Um, so we already completed uh, pretty much the first half of the course, which we're studying charges, and then we kind of learned how this physics powers our daily life. Well, now we're going to be moving on to studying light. One of the fascinating things that I like about physics too is pretty much all of this technology, right, is tied together. So again, if you think about all the material that we have, everything's made up of charges, right? Either electrons and protons, it's all matter. And then we learn about the phenomenon of electrical forces and stuff like that, and that just powers our everyday devices. Well, optics is going to be basically the other side of the picture, right? Um, Optics is how we see the world. So just about everything we experience comes with some interaction of light. So just kind of like what we did, we're gonna start going over some elementary ideas of what optics is, right? So we talked about, like, for the charges, we talked about some early ideas of how charges work. So we're gonna do the same thing, but we're gonna do that with light now. So we're going to talk about reflection, refraction, then we're going to move into lenses, concave mirrors, and then we're going to learn some a little bit more advanced properties of light. Um, because light is so important, I just kind of want to give you a brief introduction of what light is and what are we going to be talking about in this optics portion. Again, all this physics is related to each other, right? So if you think of something like how a solar cell works, you have light coming in, and it hits a solar cell, that's energy, and it gets converted into charges. So all of this physics pretty much describes how we experience our world. So I want to begin with one of the what I think more interesting things is what is light, right? Well, light makes up almost everything, but you're probably more familiar with like the light that we see or detect with our eyes, which ranges from typically 700 nanometers to 400 nanometers. This is known as a visible light. This is the light that we could see. But light makes up a broader region of, of the spectrum, right? So, for example, if you go to a doctor and you get an X-ray, they're actually using X-rays, which is a form of light, and we have special detectors, so you can X-ray yourself. Um, if you ever heard, if you know about nuclear power plants, you've ever heard the term radiation. They give off gamma rays sometimes, which is very, very dangerous. But that's another form of light, right? We can't see it with our naked eyes, but you could experience it when you get a radiation burn. The same thing like the UV light, right? So when you go outside, the sun's beating down on you and your skin's turning red. You can't see that ultraviolet light typically, but you could experience or sense it with your skin. So this is high energy light. It's not really relevant for today's lab, but just to let you know. But we also have low energy light, right? So like microwaves, basically what we're doing when you put something in a microwave is we're shining light on it, and that light typically vibrates water molecules in your food and it heats it up. So that's another form of light. Radio, it's a lower energy light, but this is how we listen to the radio. So basically, the towers are shining light everywhere, and we have detectors that pick up on the signals. Even our internet, right? It's not on here, but the internet now we are on 5G. It's in the gigahertz region, but the internet is towers works pretty much similarly. It's broadcasting that light, and then your computer detects that light, and it talks to each other, and we could experience this virtual world or this metaverse, right? Um, this is how we're communicating right now through Zoom and videos and such. So it's very fascinating that light makes up pretty much all of our world, our communications, how we sense the world, how we experience the world. So light is a very fundamental, important thing of physics, right? So for our purposes, we're going to be looking at light at a very elementary level. And when we use the term light for these next few labs, we're basically going to be only focusing on visible light, the light that we could see with our eyes. And of course, when you have all these wavelengths mixed together, the white light looks white. right? So light is one of these very fascinating. So in this week's lab, we're basically going to be talking about one of the very elemental fundamental properties of the behavior of light. And we're going to be talking about reflection and refraction. So essentially what we want to do is have an understanding is how does light move through the air, different materials, and how does it behave, right? So pretty much you can have light, it could go hit a material such as water, it'll refract, um, or sometimes it could reflect, right? And we're going to also study this idea of what a critical angle is, but this is basically what we're going to be looking at in this first lab of optics. We're going to be looking at how does light behave, right? How does it travel through a medium, and how does these uh, waves behave in general. So we're going to be looking at reflection and refraction. There, it's pretty straightforward, right? So you may have seen the TikTok video, right, where they're like, "Oh, the mirror can see behind your hand." Well, no, it can't. It's just basically using the idea of reflection. So again, so this is what we're going to be doing this week. So what is the law of reflection? Well, it's very straightforward and it's intuitive. So it should be feel very natural, right? But basically, what the law of reflection is, it says that the angle of incidence is going to be equal to the angle of reflection, right? So we always measure from this imaginary line called the normal. So when you have like a light beam, like you could pretend like this is a laser coming in, right? Once it hits the surface, we are going to draw the normal there. And we always measure the angle closest to the normal. So this is our incident light. Here's the normal. This is the angle closest. So if we measure this, let's say it's like 30 degrees, then we know that the angle of the reflection is also going to be 30 degrees. So this is all the law of reflection says, right? So no matter where the light comes in, if it comes in here, it hits and it bounces, like let's say this is 40. If it comes in at 45 degrees here, then it's going to leave at 45 degrees. Very, very simple, very straightforward, very intuitive. So you shouldn't have any difficulties here. You're going to go into simulation, but it's almost so simple it's trivial. But this is the main idea of the law of reflection, so we should know that. Now, what's a little bit more complicated is the law of refraction, or in other words, we call it Snell's law, right? So this is what happens when we have a light beam come in, right? Let's say this is air, and then it goes into a medium that's more dense, such as water. It's going to refract, right? So you might have been a kid like putting a pencil in the glass, right? And you saw that the pencil looks like it's broke, or like it's broke a little bit. Well, that's refraction. So the white light waves are bending. Um, Now, what Snell law describes this interaction, right? And it's given here, right? Where we have the refractive index of our incident light. If it's air, this Ni is going to be 1. Um, and then we have the angle of incidence, right? Theta I. And remember, we always measure closest to the normal. And notice that when you're going into something more dense like water or a different material that's going to be more dense than air, it's always going to refract closer towards the normal, right? So when we take the measurement of our refractive angle, we're going to actually measure this angle here. So this is your theta I, your angle of incidence, and this is your angle of refraction. So it's very important that we always measure the angle closest to the normal. All right. In this week's lab, you're going to know, right, that your light is going to be coming from air. You're going to know this angle, and then you're going to know this angle. This is a very easy equation to solve, so you're going to be solving for uh, uh, your material's refractive index. So we're going to use Snell law to calculate the refractive index of an unknown substance. So we know that we're going to be having light coming through air. It's going to go through some material. It could be some form of glass, some form of plastic, something that's clear. It's going to get bent, and then you're going to calculate this refractive index. We're also going to look at the case of something known as a critical angle. So this is the angle which happens, like if you set this to 90, um, this is the angle which total internal reflection starts, right, to happen. So the equation's given here, but this is a situation where you have light coming in, it hits the surface, right? And then when it's 90 degrees, this is the critical angle. After you pass the critical angle, total internal reflection starts, right? So this is the concepts that we're going to need to know for this week's lab. Again, it's very simple. So if you have any questions, you can email me. But um, I just want to stress that optics is going to be a lot of fun. So yeah, this week's lab is going to be a nice breather, right? Because last week we were doing Kirchhoff's law, and that was very, 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 very stressful. Or actually, a lot of math. But this week the math should be very straightforward, so it should be a little break math-wise. But conceptually, I know this lab seems very simple, but light is very fascinating, right? Because once we move on, we're going to be talking about pretty much smoke and mirrors, right? Thin lenses, concave mirrors. But once we pass that, we're going to get into our last lab, which is what I find fascinating. It's the properties of light. So you might have heard that light could act like a wave and a particle. So that's going to get into deeper physics. But just keep in mind that all this physics is related to each other. So we're kind of starting to come to the end of the semester. Um, but yes, but everything here pretty much makes up our whole world. So thank you for listening. If you have any questions, please feel free to come by my office hours, and I'll be more than happy to answer them.